Okay guys, welcome back to my channel. Now, continuation of motion of connected particles. Now this is case 2. Now what does case 2 entail? We have two masses again. One of the masses on a platform and the other hanging freely from a pulley. They are both connected by a light inextensible string across the pulley. Now this platform is going to be a smooth platform, meaning there will be nothing about friction in this question. Again, how do we find the acceleration? We are told that the object is moving downward in this direction, meaning the mass m2 is dragging the object down in that direction. Now, we're going to again bring out two equations for mass 1 and mass 2. Now, looking at mass 1, what are we going to bring out? For object 1, we agree that it is somewhat of this nature. Okay, the mass is acting, or the weight is acting downward. Now, because of how it is moving, mass 1 is moving this direction. Now, because of how it is moving, you agree with me that the weight of the object will not have anything to do with the motion, because since it is a smooth surface, the entire moving force in that direction is just the tension as it is in the diagram. If there were to be a case of friction, therefore friction will act backwards, we'll then say tension is greater than the frictional force. Since there is no frictional force, we'll just say the tension is what is causing the motion. So for case 1, we can just say the tension T is just equal to M1A. This is equation 1. Now for object 2, we've done it before. In our previous video, we explained what occurs for object 2. So I wouldn't want to waste your time. We'll just say for object 2, the tension, if you remember, was equal to M2G minus M2A. This is equation 2. If you have an issue trying to understand this, go to the previous video under case 1. It was explained perfectly in that video. Now we have two equations, T equals M1A and T equals M2G minus M2A. Remember, T equals T. We're going to equate them to find the value for A. Okay, M1A equals M2G minus M2A. We need A, so the value that has A should come to me the one that has A. So we have M1A plus M2A equals M2G. Recall, A and A is common. I bring out one A, open a bracket. We're going to have M1 plus M2, close the bracket, equals M2G. Now what's next? We're looking for A, so we're going to divide both sides by M1 plus M2. So we have divided by M1 plus M2, same thing on the other side, M1 plus M2. So this takes out this, and therefore the acceleration in this case becomes M2G divided by M1 plus M2. This is the acceleration for case 2. Now recall, you can find the tension by putting the value of A into either equation 1 or equation 2 as we did in case 1. Now what's next? The force. How do we get the force in this system? Looking at the way the tensions are acting, they are acting perpendicularly to each other. We call in vectors, when you have two vectors acting perpendicular to each other, you're going to apply Pythagoras theorem. So we have a T here, we have a T here. First of all, you resolve the diagram. Now this diagram is not resolved. How do I know? The head of one vector is touching the head of the other vector. Now that is wrong. How do you resolve a vector? The head of one must be touching the tail of the other. So I'm going to transfer or transmit a line. I can transfer this line up to this part. Watch, observe, I'm using parallel lines to show this same line on this part. It is still pointing upward. Now the head of this vector is touching the tail of this vector. So therefore it is now resolved. You then close up your triangle, and then this value becomes the resultant force. We have T here, a right angle triangle. Applying Pythagoras theorem says the hypotenuse becomes square root of the other two sides squared. If you solve that completely, you're going to have square root of 2t squared. Now remember, sword. You can share sword when it's multiplication. So we then have square root of 2 times square root of t squared. The square root can cancel the square. Therefore, the force in case 2 becomes t square root of 2. Remember, the acceleration is given here. The tension can be gotten from either 1 or 2, and the force is t root 2. Now this is all about case 2. Heading on to a question. Okay, now a question from case 2. Now they said we have two masses. One is resting on the platform and the other is hanging freely. 4 kg and 6 kg are connected by a light inextensible string over a pulley, and we are asked to find the acceleration in this system. We can as well find the tension and the force. Now, from our previous derivation, all the formulas we need are on the board. Now, let's move on. Most times in questions, you might not be told it is resting on a platform. This mass can also be called a glider. A glider. Why? It can glide on the platform. Now, since the motion is moving this way, what we did before remains the same. So we can see, how do we find A? A will just be equal to, remember, M2G. Who is M2? The mass hanging freely is the M2. So the M2 is 6. So we have 6 times G is 10 divided by M1 plus M2, which is 4 plus 6. Now this should give you 60 over 10. If you divide, you're going to say 0 takes out 0, and the answer becomes 6 meters per second squared. As simple as that, right? Now, let's find the tension. Remember, you can either apply equation 1 or equation 2. But when you check the two formulas, equation 1 looks easier and faster. We're going to apply equation 1. Now, what is equation 1? T equals to M1A. What is M1? 4. And what is A? 6. So therefore, the tension becomes 24 Newton. How about the force? Now, the force in this system, remember, is T root 2. We're going to say 24 root 2 Newton. And these are our answers for this question. Alright guys, we're going to look at the next case in the next video. Please, if you're just seeing my video, try and subscribe, like, and share to your friends and loved ones. God bless you.